5, we're going to take a look at something called factored form. First, we're going to review what we looked at yesterday, which was if I give you a quadratic function in vertex form, can you identify the vertex of the function? So if you take a look at the first one, we have x plus 5 squared minus 3. And if you recall, this would shift our graph left 5, down 3. And the graph that we're talking about is a quadratic with the parent function y equals x squared that has that vertex at 0, 0. So if we shift it left 5 down 3, the vertex would be minus 5, minus 3. Our second graph doesn't shift left or right any, but it does go up 10. Oopsies. And so our equation would be 0 because it doesn't go left or right, but it does go up 10. And then our last graph, it goes to the right 1 and down 7. So it would be 1, negative 7. So if you look at the pattern, if it's in vertex form, it's always the opposite of the number inside the parentheses for your x value. And then the number on the outside, the k value, stays the same. So you should feel comfortable giving me the vertex of an equation, vertex of a function, a quadratic function, if it's in vertex form. All right, let's go backwards. Can you write the equation of the quadratic in vertex form? So this one just goes to the right 3. So it would be y equals x minus 3 squared, and it doesn't go up or down. So you can put plus 0, but you don't need it there. This graph goes left 3, down 3, down 4. So here's what the function would look like. Y equals x, and then for left 3, it will be plus 3, the opposite. And then you're going to square it to get that quadratic. And then down 4 will be a minus 4 on the outside. So again, if it's in vertex form, left and right are opposite in the parentheses, and then up or down is the same. So up is plus, down is minus. So that's just a quick review of what we did yesterday. Our goals today, though, is we're going to take a look at a new form of a quadratic. So quadratic has many different forms, and one of the forms is called factored form. So today you're going to use what you know about an equation in factored form to find the x-intercepts of a quadratic. You should be able to write the equation of a quadratic in factored form. Disclaimers, when I say the word x-intercepts, here's what I'm talking about, these 2 points right here. They're also called the zeros of the graph, because they are at the point where y equals 0. They're also called the roots of the graph, because when we learn something called quadratic formula, we use a square root to find the zeros of the graph. So x-intercepts may be also called zeros or roots, or like solving the function. All right, so your goal is to complete the day 5 factored form in Angry Birds Desmos. It's going to explain and illustrate, like, what does factored form tell you about a function, and then we'll summarize in class. All right, so the summary after you do the Desmos will look something like this. Factored form of an equation is in this form y equals a times x minus r1 times x minus r2, where r1 and r2 are the x-intercepts. All right, and then we'll quickly go over y right now. I'm just going to pull up another sheet of paper. Here's an example. Let's say you had y equals x minus 3, x plus 5, and we want to find where that equals 0. So really, this is two equations in one, because if this side, x minus 3, if that whole thing is 0, it doesn't matter what this side is, because 0 times anything is 0. And likewise, if this number is 0, it doesn't matter what the other factor is, because anything times 0 is 0. So you can use this thing called zero product property. X minus 3, when does that equal 0? And if x was 3, and you plug that in, you would get this to be 0, and 0 times anything is 0. On the other side, you would say, all right, how about this one? X plus 5 equals 0. If we were to solve for that, we can see x equals negative 5, so negative 5 is the other 0 of the graph. Let's see what that looks like when we actually graph it. You should expect it to cross at x equals 3 and x equals negative 5. So I'm just going to pull up Desmos, the graphing feature of that, and then just type in the function. So it was y equals x minus 3, oops, and then x plus 5. Oopsies. So you can see, again, it's your quadratic. You can see the minimum point right there. And there's two x-intercepts. One's at 3 and one's at -5. And so the pattern that you really start to notice as you work through the Desmos is the zeros are just the opposite of what you see in the parentheses. And again, it comes from this thing called zero product property, which makes each factor 0. So let's do one more example. And again, if you did the Desmos, you worked through many of these. If I have x plus 4, x plus 2, what makes this one 0? And that would be x equals -4. What makes this one 0? And that would be -2. And if we graphed it, you'd expect it to cross at those 2 points. So I'll just quickly shift our graph here. And you can see that, yes, it is the opposite of the zeros, or of the number inside the parentheses, to make it 0. So the main idea, again, for factored form is if you see these parentheses, these are factors, they multiply to the quadratic, and the opposite of what's inside the parentheses are the x-intercepts, or the zeros. So that's the main idea, and we will review that and continue on in our investigation of quadratics tomorrow.